So welcome back to arrays. In this class, we are going to perform a deep dive into arrays. And we'll simply do this by creating a program. Let's say a program that will be having numbers, and then it will output for us the smallest, maybe fifth element, the smallest fourth element. Given an array, for example, like this, 12, 13, and 14, this is an array with 5 elements. Therefore, the program should, remember, the user can enter this array, which could be unsorted. This is sorted, but the user may enter random integers. Therefore, the program should be able to sort these integers out in C, and then the program should also be able to output. Let's say, for example, the second smallest element is 11. Also output the fourth smallest element is 13, given the user enters such array like what we have there. So I'm going to move straight to where I store my C programs. And you're going to see other programs that we have been working on previously. I'm going to create a program using Nano that will have, I'll call it get smallest, or maybe get, I'll call it get smallest. That could be a good name. Get smallest.c. I'll have my hash include std IO, standard input output header. I'll define a constant size, maybe of 20, which will contain the array size for this case. So I will then move to my int main. I will declare an array of size A, or of type with a name of A, and then with the size of 20 there. I will declare an int I, a counter for the first loop. I'll also try to loop again, as you will see, and then also declare a temporary value, or a temporary variable to store the current, maybe let's say the smallest element for this case. And then, as you'll see the program, I'll move straight to from the user to enter the number of elements, because they must tell us beforehand what is the size of the array, and therefore we'll also have another declaration there for n, and then I'll receive through scanf the number of elements in our array in this case. So having done that, then I will successfully have received the number of elements. From there, I can use a counter or a loop, which will be able to go all the way to I less than n. Remember, it starts with the zeroth index, as we've seen in the other lesson, all the way to the end index. The end index minus 1. So if we enter 5 elements, then the last index is 4, as you see in the other time. So I'll increment that. And then I'll come here and print the screen and tell the user to enter the first or the second element. This will be simply given by I plus 1. So having done that, then I will receive the element itself and store it inside an array. The array itself is A, and then I'll put I there, the index, and then I will end there. So at this point in time, I have received an array of my integers. So the next thing would be, I'm assuming now I've received int, maybe let me be having this int A 5. I specified maybe n as 5 this time. Then I have 10, 12, 23, 9, 16, maybe 30. That 1, 2, 3, 4, 5. So given such elements that the user, maybe we assume that they have maybe entered this as an example, then what is the reasoning behind what we are about to do? The first thing is that the user will come in here and try to take maybe 10. When they take 10, they will compare 10 with the rest of the array. If 10 happens to be smaller than the rest of the array, then 10 remains in its position. Otherwise, if 10, this is now where you are sorting. If 10 happens to be then greater than the rest of the array, let's say 10, of course, here is greater than 9. So then we'll have to swap the two numbers, and then temporarily, of course, we'll store the new value of, we'll have a swap and we'll be using temp for that matter. So in this case then, therefore, I'll have a for loop, and I will loop from I. Remember, I will start from the 0th index. I'll compare it with the rest. I'll come to 23. I'll compare it with the rest. I'll come to 9. I'll compare it with the rest. And the last element will be 16, which I'll compare with the rest. I cannot compare that with that. And therefore, this loop comes all the way from 0 to n, all the way to 0 to n minus 2. So this loop will end at 16. That's what I am saying. So for I is equals to 0, I less than n minus 1. So it will go all the way to I, all the way to n minus, because it's less than, all the way to n minus 1 for that matter, or n minus 2. Less than n minus 1. So and then I plus plus. So this will be the outer loop. So I can come and end it here. So this outer loop simply means the first time I will be 0, and then inside the inner loop, we will have to loop all the way. So we'll have our inner loop here, where we'll come and loop maybe j is equals to 0, and then j, it starts, remember, the inner loop starts at the outer loop, for the first time the outer loop will be 10, and then we compare 10 with the rest of the array. So the inner loop now, for j must start at, if I, for example, is the 0, then the inner loop which starts from here all the way up will start at 23. And in this case, it is j will be initialized to start at I plus 1. Maybe I will re-explain this again. We are comparing 10 with the rest of the array. And the rest of the array part is the inner loop. Then the second time, maybe we are comparing 23 with the rest of the loop. So when we start at 23, our index will be at position 1. And therefore, j now will start at 23, where we could be comparing 23 with the rest of the loop. So from there, for the j less than, it will go all the way to 30, j less than n, and then j plus plus. So what should happen if that is the case? So if that is the case, then what should happen is that we'll have a temporary value. We'll come and try to compare is the value itself, is 10 less than the rest of the array? If it is less than, is it greater than the rest of the array? If it's greater than, then we will push it forward. So we'll come and compare if one, we can compare if ai is greater than aj, if it happens to be that ai is greater than aj, then this is what will happen. So I'll come here and assign the temporary to be temporary value. If ai is greater than, then the temporary will be assigned to ai, meaning it is greater than. And then what was in ai originally will be assigned to now the last value, which is now aj. And then what is in aj, or what was in aj now, the original value, we will take the greater value there, which is the temporary. And from there, we'll have done our swap well. So from there, we'll sort the array, and then maybe we can come and prompt the user to print f, and we'll ask them enter maybe the second smallest element. So if the user enters the second smallest element, then it should output, they will allow them to enter that. Scan f %d, then ampersand. Let's assume we have another value here called k. another variable called k. Then what should happen with our program is that ampersand k. So the program should print f to the screen and say the whatever smallest element is, then the kth smallest element is, of course, now our array A, and then the value of k minus 1 because an array starts at index 0. So from there we return 0, then we'll end our program there. So we are saying that if this enters, let's say the second smallest element, then as k, if k is 2, then of course you all know that the second is the first, this is the second is at position 1, 0, 1. That's why we are saying k minus 1 there. Then of course this should end with a semicolon. I'll try to compile my program. GCC, not GCC, but GCC get smallest, let's see, I'll output get smallest. Hoping all goes well. I made a mistake, get smallest. Okay, there is an error. Scanf expects this to be of type int. Maybe I'll go back and look at that on line 11. Scanf. Okay, I didn't use the address here. I should have used the address of operator there. Then I will exit, recompile, another error. Expected end of inputs. I go back, return 0. Try to go through my program and see whether we have an error. If I spot the error, then I will simply be able, okay, there's an error here because this loop is not closed. We should have closed this loop here. The internal loop should have been closed because and then AI. Okay. Trying to debug here. I'll recompile. Error. Enter the smallest elements. I made another mistake. This one here should be enter the enter the smallest element, or enter the position in the smallest element. Okay, things seem to be working now. Get the smallest. Enter the number of elements. I will say there are 5. Enter element 1, 10, 9, 15, 13, and 19. And enter the n smallest element. I want to know maybe the then smallest element. The then smallest element in this case is 13. 1, 2, 3, 4,